3000 minus 0 by 3000. When the rotor speed is 0, that means the boy is sitting in the last bench. He didn't bother about the first bench girls. So it is the far away. So in this position, whether the rotor is rotate or not, does not rotate. So, but even though in this case the motor does not rotate, what is the slip? 1. Now, if S is equal to 1, if S is equal to 0, both the cases motor does not rotate. Correct? If S is equal to 0 also, the motor, if S is equal to 0 means the boy, the girl is accepting proposal and sitting in one places. S is equal to 1 means it is not started. In both the cases, the motor does not rotate. You forget about the concept again. We need to remember this point. It's too important. This question frequently asked in the exam. So this question is concept-oriented questions. And we have a question by using these formulas. By using this formula, we have questions. Okay, now, so hope most of the people we saw the induction motor. So in the induction motor, the nameplate, they mentioned the voltage rating, frequency, and what rated speed. They mentioned the rated speed. So, for example, they mentioned 1440.
If we have NS is equal to 0, then what we will do?
NS is equal to 0 means what is the meaning? We didn't give any supply to the stator. NS, the speed is the speed of the rotating magnetic field. The rotating magnetic field is imaginary. That is the speed due to the field winding, that is stator winding. That means we didn't give any supply to the motor. Okay. So in the nameplate detail, they didn't mention the synchronous speed, especially for the induction motor. In the induction motor, they didn't mention the synchronous speed. But in the nameplate detail, they give the voltage, frequency, and the speed. The speed they mentioned in the heading, they call as rated speed. Okay. Now, can we find number of poles in the motor, in the particular induction motor? Can we find this? For example, in the given data, the frequency voltage is 440 voltage, frequency is 50 Hz, rated speed is 1440. Find the number of poles. So this question asked in the exam. So now you always we find the formula from the question. Here we need to find the number of poles. What is the formula for the number of poles? NS is equal to NS is equal to 120 F divided by 2. This is the formula. Okay. So frequency is 50 Hz. 120 divided by 7. This is pole. We need to find the poles, which is incorrect. Whether in the question paper they give the synchronous speed? No, they give only the rated speed. But formula we need to put the synchronous speed. So here, based on the value, rated speed, because the rated speed means it is the maximum speed. The rated means at the maximum, we can able, if the motor rotate 1440 RPM, it will give the maximum efficiency. The other full load efficiency like this levels. Okay, so in this time, to find the number of poles, we go for the reverse method. That is F poles speed. Here 50 Hz. We need to find the number of poles. But we know number of poles is multiples of 2. So we substitute 2. At that time, then we have a 3000 RPM. If you put a 4 poles, 4 pole, 1500 RPM. 6 pole, 1000 RPM. 50 Hz is because in the nameplate detail they mentioned the 50 Hz. Now the motor in the nameplate detail, the value is 1440. If the motor having 6 number of poles means we are not able to get the 1440 RPM. So number of 6 pole is ruled out. So the induction motor having either 2 poles or 4 poles. Okay. Suppose if is maybe a 2 or 4. But which is the nearest number? 1500 is the nearest number. So we chose the 4 poles. So why we choose the nearest number? Okay, suppose if we choose this number is 3000 minus 1440 divided by 3000. What is the slip? The slip is more than 50%. So usually that type of induction motor we didn't prefer that. Okay, so that's why we choose the nearest value. So that the number of poles in the induction motor is 4. And as I told, these type of questions you must carefully see the frequency. Okay. And apart from this, what is the tentative percentage slip? So now the motor is classified into 3 categories. One low size motor, medium size, large size, like this. They are categorized the motor. For the small size, in general the slip is 6%. For the large size, we have a 2%. For medium size, we have a 4%. So the 4% sometimes asked in the exam. What is the typical value for a slip for a medium size induction motor is 4%. So 2%, 4%, 6%. For large, medium, small. So just to calculate 1500 minus 1440 divided by 1500. The value becomes 4%. Because 1440 RPM mostly we saw in the induction motor. Even in our home, we are using a bed grinder. In the bed grinder, they mentioned the 1440 RPM. So similarly, 3000 into 3000 minus 2900 divided by 3000. So at the time also we are getting the almost 4% slip. So this is the typical value. We must by the values. Okay, now. So in the induction motor, they classified into based on the supply. Where we give supply? In the stator. Which type of supply we will give? We are giving the either single phase supply or 3-phase supply. So the induction motor is classified as a three-phase induction motor or single-phase induction motor. This is classified based on the stator. Based on the rotor, we are classified as a squirrel cage rotor and slip ring induction motor. It's a broad classifications. Squirrel cage induction motor, slip ring induction motor. Usually this motor, we use the word SCIM. If you refer the IEEE paper, they mention SCIM. Squirrel cage induction motor or SRIM. SRIM stands for slip ring induction motor. Or sometimes we call it a wound type. So as I told, yes, there is a rotor, the rotor becomes short circuited. So it depends upon our requirement. We may short circuit to the coil, or the short circuit is done by the external supply, external unit. If you have an external unit, means we go for the slip ring induction motor. So internally short circuited means it is a slip ring. So easy to visualize. See. So this is the squirrel cage rotor. Squirrel cage. See here, this is the slot. The blue color represents the slots. And it is represent the laminated core. So in between this core, we have a coil. So here, see here. So this is the one slot. In this slot, instead of coil, they put a copper bar. They put a copper bar. So then, like this. The copper bar represents one resistance. So this is, so another copper bar will represent another resistance. So here we have one end, so another end in the other side. So like this we have here. But as per definitions, the winding becomes short circuited. How we make a short circuit? So this end becomes like this and here like this. Now it is a short circuited winding. Okay. Now simply I draw the line, but especially in the squirrel cage induction motor, the short circuited like this. So this circle we call as a end rings. So this question asked in the exam. In squirrel cage induction motor, the rotor are short circuited by end rings. In the both sides, we are putting the end rings. Now see how much resistance value will have the squirrel cage rotor, because each bar is connected short circuited. In the parallel circuit, the resistance value is less value. So the squirrel cage induction motor always having low resistance. Due to the low resistance, the squirrel cage induction motor having a constant speed. So squirrel cage rotor having a low resistance and having a constant speed motor. So now reversely, if we need a variable speed, high starting torque, what we do? We need to vary the resistance value. Okay? It is not possible here. here we are using the end rings. So here not possible. So at that time we have a winding. In the one end we are putting the end rings. In the other end we have here windings. R phase winding, Y phase winding, B phase winding. And these windings are short circuited in the one end. In the other end, now here the rotor having a winding and one end is short circuited, other end we kept in the outside of the stand motor and connected with the external resistance. By adjusting the resistance, we can be able to increase the total resistance value. So by this way, we can be able to change the speed of the induction motor. It is happened in the slip ring, not in the screw cage, because the screw cage we are not able to add the external resistance. So this is the, by adjusting this knob. So this is what we did in our college by rotating the shaft, top of the, by rotating the shaft by increasing the rotor. So the entire setup we call as a rotor resistance type So usually this is used to type starter. This may be a starter, it's used as a starter as well. We can be able to increase the speed also. Okay, it is happened in the slip ring only. So that's why we call as a wound rotor. Okay, so we come to our exam point of view. Screw cage rotor, constant speed, constant torque. Slip ring induction motor, variable speed, high starting torque. Okay. Now, see here, it is not a straight line. It is a slightly skewed. See here, it's not a straight line. So why we use the skewed rotor is important. This question asks that exam. Especially not only in the road. Okay, in the rotors, we have a skewed rotor. We are using the skewed rotor to avoid the magnetic locking and to avoid the humming sound. To reduce the magnetic humming noise, stalling of the rotor means magnetic locking. So that's why you go for the skewed rotor. Magnetic locking. See here, just to hold the thumb, we have things. So if you pull up like this, so that's it. Suppose if you like this, is maybe fell down. So we avoid the locking. If they are like this, it is also magnetic field. It's also magnetic field. One particular point is locked. So to avoid the magnetic locking, just we go for the skewed things. So frequency means it depends upon the rotation. Okay. So in the transformer, both primary and secondary have the same frequency because there is no rotation in the field secondary winding. So that's why both have the same frequency. But in the same motor, the stator we are giving a 50 hertz. The rotor is rotating its own frequency because it's generating its voltage and it's rotating its own frequency. The frequency is always less than the supply frequency. Less than the frequency, supply frequency. Here we use the two words. One is FR, FS. Like NR, NS, NR. NS stands for stator synchronous speed, rated speed. Similarly, FS stands for synchronous frequency. Synchronous frequency nothing but what we give. We are giving 50 hertz. So that's why it is a synchronous frequency. FR stands for rated frequency, specifically rotor frequency, because rotor is rotating. The rotor frequency, the formula for the rotor frequency, which is equal to S into Fs. S into Fs. How to find the S? Suppose if you are more unlucky, means you may have a problem like this. Because in this problem, the given data, they give a frequency, okay, they give the rated speed. We need to find the slip frequency. So to find the slip frequency, we need to find the slip. To find the slip, we need the synchronous speed and synchronous rated speed. In the question paper, they give the rated speed only. So first we need the synchronous speed, then we need to calculate the slip, then we need to find the slip. It's not the toughest one, but we have a lengthy process. At the same time, if you are more lucky, they say that the given data, they give a slip percentage. Slip is 4% and frequency is 50 hertz. Find slip frequency. So directly 4% into 50 gives 2%. And important thing, keep in the mind, in the transformer, primary winding, secondary winding, having same frequency, the induction motor, we may call as a rotating transformer. Induction motor, we call as a rotating transformer. Hope in your college, you have a question. Indirectly, in the lab, they have the indirect questions. Instead of induction motor, they may call as a rotating transformer. So rotating transformer, nothing but a induction motor. So here, the speed is not equal in the stator and rotor. Now we have induction motor. This induction motor shaft is connected to the mechanical load. Okay. Now we remove the mechanical load. We are giving the power supply. What will happen? The motor is rotate its own speed. That speed, we are getting a speed in the rotor. But we say that speed we call it a no load speed because the shaft is not connected to the load. So that's why the speed we call as a no load speed. See here, the nameplate detail they mentioned that 1440. That means the nameplate detail mentioned that the motor is connected with the appropriate, the recommended load. At that time, the speed is 1440. So that's why the synchronous speed is 1500. So slip is 4%. Now the recommended load is disconnected. Mechanically is disconnected. Now, yes. Now we measure the speed. the speed is greater than 1044 or less than 1044. Yes. Assume that I am riding a bicycle with one person. Now the person is left. Now my speed is increased or less? Increases. That means the speed is 1480. So that means 80. That means the slip is increases or decreases? Decreases. Okay? Correct?
Why you put the 1500? Why we cannot put the 3000?
Hello, sir?
3000.
1500. So this is the full load speed, rated speed. This is the no load speed. So that's why I say that in my bicycle.
Synchronous speed, sir. Synchronous speed. We can put 3000 also.
Okay. So if you take a, for example, the induction motor rated speed is 2900. The rated is 2900 means the synchronous speed is 3000. Okay, I understand this one. So here is 4%. If the no load speed is the rated, the rotor speed is increases, so that's why the slip is reduced. Sometimes I am riding a bicycle. One of my fellow men pushed the bicycle too fast. What will happen? I ride the bicycle over the speed. So that means it's here 3100. This also happened due to the in our processing industry, due to the malfunction, the mechanical load is driving more fast because it is interconnected with the other motors. So at that time the speed is increases. So it will maybe happen like this. Here we have a negative slip. When we get a negative slip, if the rotor is rotate in the above the synchronous speed. So above the synchronous speed means we have a negative slip. So at that time the induction motor is behaving as an induction generator. This question is rarely asked in the exam. So above the synchronous speed, slip is negative. The induction motor is behave as a induction generator. Because at that time it just acts as an alternator. So the alternator, we are giving mechanism in the shaft, we are getting output in the stator. So that's the time it behaves as a generator. So we have no questions from this area. So we forget about the top for the induction motor. So as I said, induction motor is similar to the transformer. So you can able to visualize this. So it's an induction motor. This is the stator. Here rotor. So stator, this is the stator. So similar to the transformer, primary winding. In the secondary winding is a rotor, just like that. So this question frequently asked in the exam. Frequently asked the question, but see the answer carefully. Read the question carefully and cite the answer carefully. In the transformer, forget about the induction motor. Just take a transformer. In the transformer, we need to conduct a no-load test. How we can find the core losses? We have two tests on that. One is the no-load test, another is the short circuit test. Okay. From the no-load test, we need to find the core losses. How to conduct the no-load test? We have a transformer. In the transformer, we giving the AC supply in the primary. In the secondary, we have no load. Is connected in the secondary. So that is the circuit diagram for the no-load test for the transformer. Correct? Okay. Now, if we conduct a no-load test for the induction motor, what we do? We remove the in the transformer, we remove the electrical load. Open. In the induction motor, we remove the load. Which type of load we are giving? We are giving a mechanical load. How you remove the mechanical load? We connecting the mechanical coupling. So it is a mechanically coupled like this. So just like a mechanically coupled and we remove the couple. At the time, the induction motor is just like here, no load. So even though it is a no load, even though the induction, it's a no load. Now the induction motor is rotating as a no load. But equivalent, what is the equivalent circuit? The rotor, even though it's a no load, it's a block rotor, normal condition, the rotor is a short circuit. But here the question is equivalent. In the one hand, we have an induction motor. In the other hand, we have a transformer. Now, we need to compare the induction motor to transformer. And we need to compare the induction motor and at no load condition. At no load condition, transformer is said that is the circuit. So that's why open circuit and secondary. So this question frequently asked at exam. So without changing the word. As of now, they ask the no load test. And this question. So just to show that if you are unlucky, we have the first question. In a 50 Hz induction motor, the no load speed is 2900 RPM. Here we have one missing data. We need to give a study. Okay. 50 Hz, they mentioned that. So 50 Hz, no load speed, NR. This is NR. This is Fs. We need to find slip frequency, that is S into Fs. To find S, Ns minus Nr divided by Ns. So in the given data, Nr is given. So we need to know Ns. How to know the Ns? Depends upon the rated speed. We predict that this motor having 4 poles. So that's why the synchronous speed is 3000. 2 poles, 2 poles. So that's why the synchronous speed is 3000. Okay. Now we can be able to find the slip. We can be able to find the slip frequency. And next question also frequently asked at the exam. If the motor running with a heavy load, assume that in my I am riding a bicycle. In my bicycle, 3 to 4 persons sitting in my bicycle. So to walk, I ride a bicycle. Suddenly, four persons is move from my carrier. What will happen? What is the speed of my? I ride with more speed. So this is the condition. Unfortunately, in our process industry, the drive is disconnected with the mechanical load. So what will happen? Immediately is run too fast, then is settled down. So initially the motor will speed above the synchronous speed, then it is settled down and in the normal speed. Momentum, yes, momentum. Due to the inertia, momentum is rotating too fast, then it settles down. So just as I told, so induction motor running at a single speed, what will happen? The boy and girl sitting in the one place, that is, there is no moment, so that's why the torque is 0. You forget about this one and this question.